Okay, so here we're going to do a little hypothesis testing. So this is problem number 77 from our from the textbook Collaborative Statistics. So the problem states an article in the San Jose Mercury News stated that students in the Cal State University system take 4.5 years on average to finish their undergraduate degrees. Suppose that you believe that the mean time is longer. You conduct a survey of 49 students and obtain a sample mean of 5.1, and that should be years, with a sample standard deviation of 1.2 years. Do the data support your claim at a 1% level? All right. Now, when I read this, sometimes it might take a couple times to read through the problem and kind of understand, digest all that's going on here. So a couple things that stick out to here is 4.5 years on average, right? So this is from the Cal State University system. So we're going to assume that that is the population mean, right? So this is going to be mu. Okay. Now, suppose that we believe, right, you believe that the mean time is longer. All right, so it's different, right? So that is essentially the hypothesis test, right? Longer. All right. So what we have here is our null hypothesis is that mu is 4.5 years. All right. So that is our population mean, and then we come along and we're like, well, actually, I don't think that this is true. I think it's actually longer than this. Okay, so our alternate hypothesis is that mu is greater than 4.5, right? So it looks like we have a right tail test, right? So a couple of other things here. So we, of course, found some data. So we found that our x bar is equal to 5.1, and that our sample standard deviation, so I'll use S instead of sigma since it is sample, is 1.2, and our n is 49. Now we're not given what the distribution is for the population, but the sample size is large enough, and as long as we hit past like 20, 25-ish, 30, right? If we're bigger than that, right? Usually 30 is the cutoff here. Then we don't have to worry. We don't really care what the underlying population is, right? We have a large enough sample size. We don't know the sample, we don't know the population standard deviation. So once that we realize that, we have the sample one, but we don't know the population standard deviation. So